Okay, so are we ready? No, still working? Yes, still working? How many ready? Thumbs up. Okay, let's give it another minute or so. All right, so do I have a volunteer who wants to walk us through this one? Ryan, are you holding up your hand? I can't. Yes, you are, or you are not?
Yeah, I can do it.
You can do it? All right, let's try it then. Okay, so let's tell me what I need to do to get started here.
First you have to do h times a plus 4. And so you have to FOIL a plus 4 because it's squared.
So that's going to be a plus 4 squared
And then
plus,
plus 6 times a plus 4.
good,
8.
plus 8. All right, so according to my calculations, that should get us a squared plus 8a plus 16, then plus 6a plus 24 plus 8. Is that what you got, Ryan?
Yeah.
Okay, so let me stop right there. How are we doing with this? Is there a question? Everybody's good with this? Okay, all right. So Ryan, I combine me like terms here. What do you get?
8 squared 48.
What?
I got 8 squared plus 13a. Or is it 14?
That'd be 14.
14.
Yeah, plus 14a plus what?
48.
Plus 48. I think you're right there. I think that looks pretty good. So this is what h of a plus 4 is. That's a 4. But that's not where the problem ends. The problem is then asking, well, what is f of h of a plus 4? Well, let's go to the, what's my f? My f is 5x. Okay. So Ryan, how did you set that up?
F of a plus 4 or whatever equals 5 times a squared plus 14a plus 48.
5 times a squared plus 14a plus 48. Because this right in here, you know what, I should make this look a little bit nicer here. This is f of a squared plus 14a plus 48. H of a plus 4 is that. So I'm taking that and I'm sticking it in there as my argument for function f. And F just says take 5 and multiply it by your x. So this is going to get me 5a squared plus, I don't know, what's 5 times 14, Ryan?
70a.
70a plus
240.
240. And that should be my answer. Question. No, we're good with this. You're sure? Okay, then we have a word problem that we're not going to do, and more word problem that we're not going to do, and more word problem that we're not going to do, and then more word problem that we're not going to do, and another one, and we're done with 6.1. How about that? So we're ready to move on. All right, so let's go to the top here. So this is 6-2. This is inverse functions and relations. So I have 3 objectives here. I need to find the inverse of a function or a relation. I need to be able to determine whether 2 functions or relations are inverses. And then I need to compare a function and its inverse using a graphing calculator. All right. So the first question I'm going to ask is, who wants to tell me the difference between a function and a relation? And don't all speak at once. It gets to be a cacophony of voices if you're all trying to speak at once, you know. Nobody's going to tell me the difference between a function and a relation. No. Okay, well then I will give you part of the answer. A relation is simply that you have an x and a y and that they are related to one another. So if I input an x, I get a y. That's a relation. So if that's a relation, what's a function?
The function is like what you plug stuff into.
Well, I can do that with a relation too, can't I? I'm a relation, I put it in an x, I get a y.
Wait, could you explain what a relation was again?
Yeah, a relation just means I have 2 items and they're related. So I input an x and I get a y. But what's the difference between a relation and a function? Okay, I'll give you more of a hint. A relation is a function is a special kind of a relation. So all functions are relations, but not all relations are functions. What's the difference? So a function is a special kind of relation, and what it says is that for every x, there is one and only one y. I know you've heard that definition before. Right? A function is a special kind of relation. It says for every x, there is one and only one y. This is important. You should know this, right? So I'm going to give you an example here. Here's an xy axis, and I'm making like kind of a circle-ish kind of a thing. This is a relation. If I put in an x value, well, in this particular case, if I put in an x value, I could get that y value, or I could get that y value. So this is a relation, but it is not a function. A function maybe something like that, where if I put in an x value, I get a y value, but I only get one y value. Every place I put in an x, I'm only getting one and only one y. So on a graph, now I know you know this. How do I prove that something is a function? There's a test, what's it called?
The vertical line test.
It's a vertical line test. So if I take a vertical line, and let's use a different color here. If I take a vertical line and I run it along this function here, it's only going to cross my function one time every time I go across. So for every x, there is only one and only one y. Whereas up here for this circle, if I run a vertical line, well, no, I'm getting more than one. I'm getting more than one y for this whole relationship there. All right, does that make sense? Every function is a relation, but not every relation is a function. So does anybody want to speculate on why are functions so important? I mean, why are we always talking function, 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 function? Why are we always talking about functions? There's a very good reason, a very practical reason why we're always talking about functions. Any speculation?
Can you repeat the question?
Yes. So a function, every x, one and only one y. What I want to figure out is, why do I care? Like, why is that so important? Why are we always talking about functions? We talk about relations a little bit, but why are we always talking about functions? Why are functions so much more important than like a relation?
Maybe just because we use it like in almost all problems. There's always like one answer, something like that.
Yeah, I think you're getting very close. So if I'm a scientist and or an engineer, and I want to model something mathematically, which we do a lot of, right? If I can model it with a function, well, then every time I put in an x, I can actually predict what the y is going to be. Right? So I can use this for prediction purposes. Whereas a relation, you know, if I get more than one y, I mean, which one am I going to pick? I don't know. It makes it a lot more difficult. So if we can model things with functions, it makes prediction just a whole lot easier, a whole lot easier. So that's why in science, you'll see a lot of functions. Engineering, you're going to see a lot of functions. Okay. So what about an inverse function? We're going to talk about inverse relations, and we're going to talk about inverse functions. There's a little bit of a difference there. This is blah, 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 blah. The main thing that distinguishes a function from its inverse is that with a function, if I have a function, I have an x and a y. With its inverse, all I'm doing is switching the x's and the y's. That's the whole thing about an inverse, is every place I have an x, I'm going to make it a y. Every place I have a y, I'm going to make it an x. I'm just switching the x's and the y's. See my hand switching x's and y's. Okay, that's the whole trick about inverses. So let's take a look at a real example here that's good. So the notation that we use for an inverse function is f minus 1 of x. So if I have a function f of x, I am going to designate its inverse, assuming that its inverse is also a function. Some functions, their inverse is not a function. We'll talk about that as we go along. But I'm going to note it as f minus 1 of x. And this does not equal 1 over f of x. I know we're used to seeing, like, if I have a to the negative 1, that's equal to 1 over a. That notation does not apply when we're talking about an inverse function. f minus 1 of x is just saying this is the inverse of that particular function. That's the notation that we use. All right, so we're gonna skip this blah blah blah, and we're gonna do an example so that you'll see how it really works, and it's not that tough. So I have the function here. Pencil. I have the function f of x equals negative 1/2 x plus 1. They gave that to me right there. Okay. The first step in finding an inverse is let's change f of x to y, because we know that f of x and y are the same thing. So y equals negative 1/2 x plus 1. Is everybody okay with that step? Just change f of x to y. This is the step in the problem that you absolutely should never miss, because that's all it is. I'm just changing f of x to y. Now, I just told you a second ago what an inverse was. What's an inverse? Somebody give me an answer. What am I doing to find the inverse of a function? Yeah, anybody. So just turn off your mic and speak up. Joanna.
You're switching f of x into y.
That's well, close. I'm just switching the x's and the y's. So I've got right here, I've got y equals negative 1/2 x plus 1. Well, I want to make the inverse. I'm going to say, okay, well, x equals negative 1/2 y plus 1. All I did was switch the x's and the y's. That's all I had to do. And this right here is called the implicit form of the inverse. So you should know that. Just switching the x's and y's, I have an inverse, and it is the implicit inverse. But what I want to get is I want to get the explicit inverse. And the way I'm going to do that is I'm going to solve for y. So I want to get y all by itself. So I think I'll start by, I'll subtract 1. And now I have, let's get rid of that. I have x minus 1 is equal to negative 1/2 y. Is everybody right with that step? That's good. Okay, great. And now I'll continue on, and I'm going to say I still got to get y all by itself. So I think I'll multiply here by the reciprocal of negative 1/2. I'll multiply by negative 2. And if I do it on that side, I got to do it on that side. So now I have just y on this side. And on this side, I have negative 2x plus 2. So because I'm just kind of a little bit OCD, I'm gonna change this to y equals negative 2x plus 2. Got to have my y's on the left-hand side. I don't know, you're probably about the same way. And once I do that, then I'm going to say, well, I found the inverse. So y is really f minus 1 of x is equal to negative 2x plus 2. So I started over here with f of x. I changed my f of x to y. I switched the x's and the y's, which is like a very important step. And then I started solving for y. And once I got y all by itself, I said, well, I've done the inverse process, and this is now the explicit inverse of f of x.
Is that f of negative 1?
Say that one more time.
Right here. In the final, in black, what it's f of, is that a negative 1?
Yes, it is. So the notation to indicate that this is an inverse of a particular function is f negative 1. Okay, it's just, it kind of looks like an exponent, but it's not. It's just saying this is the inverse of function f. Okay, so we did that, we did that, we did that. Come on. I don't want to do that. Okay, so you want to try one?
Mr. Jenkins, can you go
Yes.
back?
Yes. To there?
Yes, thank you.
Okay. I'll tell you what I'm going to do here. I'm going to take this slide and I'm going to move it to right there. And then I'm going to so this is the slide that we just did a second ago. And if you're ready, find the inverse of this function right here. Don't bother graphing it yet. We'll talk about that later. So find the inverse of this function. Yeah, and you got the steps right over here. That's great. That'll help you. How we doing? We're ready? Okay, let's see who's going to walk us through it. 20. Joanna, you want to walk us through it?
Yeah, sure.
All right, good. Okay, let me get it all by itself here so that we can have a big screen. All right. So what did you do first?
So first I got it to the implicit form of the inverse. So I did y equals 1/3 x plus 6.
And then what?
And then I did x equals 1/3 y plus 6.
Great. This right here is the implicit form. Great. Super. What next?
Then I subtracted 6 from both sides.
Okay, so I'm going to subtract 6. I'm going to subtract 6. So I get x minus 6 equals 1/3 y. Okay, then what?
And then I multiplied both sides by the inverse on the y side, so times 3.
Excellent. So multiply this by 3 and that by 3, and we get y on this side equals 3x, what, minus 18?
Yes.
Okay, and then what'd you do?
And then I set it up as y equals 3x minus 18.
Yeah, you did the same Mr. Jenkins OCD thing. Yeah, okay.
Yeah. And then I
then?
put f of -1
Uh-huh,
x
uh-huh.
is equal to 3x minus 18.
And there you go. That is the implicit, that is the explicit inverse of that function. How do we feel about that? Are we okay? Everybody good with that? Is there a question? Somebody want to ask a question? Hearing none, I will move on. Okay. Okay, so here are two problems. You know what? I'm going to throw you out into breakout groups to work on these problems, but I want to give you a tip on this problem here first. On this problem here, I would start it out by uncommon denominatoring it. I mean, that's a verb that I made up. And I would make this 10 over 5 plus 4/5 n, or 2 plus 4/5 n. Do you see how I got to that? Everybody see that? Or should I do that a little bit over again? Over again? Okay, so I could make this, I could write this as 10 over 5 plus 4n over 5. Are you okay with that? Everybody all right with that? Okay, but I kind of don't like my variable kind of stuck there up in the numerator. So I can just change this piece right here. It's the same thing as 4/5 n, right? It's like 4/5 times n over 1. If I multiply straight across, I get 4n over 5. Same thing. But it will definitely be easier to solve in this form. And you know, if you don't want to use n's, you can use x's. It's really up to you. But so these are the two. So write these problems down, because I don't know how to share between multiple breakout rooms. And then I'm going to send you out into breakout rooms and see if you can solve this. All right, so let's, okay. Everybody got the problem written down? Okay, you can use the whiteboards in your other.
Wait, I still need to write it down.
Okay, okay.
Wait, Mr. Jenkins,
Yes,
can I do it myself?
absolutely.
Okay.
Who? Nicole, you're saying that?
Yes.
Yes, yeah, sure.
Okay, thank
so
you.
I'm going to automatically send you to a breakout room, but then you can personally, anybody who wants to do it by themselves, you can just leave the breakout room and come back to the main meeting.
Okay.
All right, that's a fine thing to do right now.
Mhm.
Okay, so let's see. I'm going to stop sharing that, and then I'm going to do breakout rooms, and let's do that. And there you go. Okay, Nicole,
Yes.
does it give you an option to leave the breakout room?
Yeah.
Okay, so you can do that whenever you want to.
Okay, thank you.
Okie dokie. Hi, Isa. How are we doing in here?
I'm confused. I'm not figuring out how to start it.
Okay. On the first one or the second one?
The first one.
The first one? Okay. So Giselle, Ryan, you okay with me talking right now, or that's okay? Okay. All right. So let me think. I think I can share my screen with just this group right here. Can you see the screen, Sydney?
Yeah.
Okay. So let's actually change it to X's and Y's. So I think we can maybe, whoops, go away. I don't want that. So I want to, so I can, so let's say this is f of x is equal to 2 plus 4/5 x. Are you comfortable with my changing it to x's?
That's fine.
Okay, good. All right. So I want to first change f of x to y because that'll make it easier. So y equals 2 plus 4/5 x. All I did was that one change right there.
Mhm.
You good with that?
Yeah.
Okay. Then now I'm going to make the inverse and I'm going to switch the x's and the y's. So it's going to be x equals 2 plus 4/5 y. Are you good with that?
Yeah.
Now, can you take it from there and solve for y?
Yeah, I think so. Thank
Okay,
you.
go for it. I'm gonna take away my screen here. You guys don't need it? Are you good?
I'm good.
Okay. Okay.
4y squared plus 12y plus 8.
I got 6y squared.
No.
Oh, you guys are working on the second problem, right?
Yeah.
Yeah. Can I give you a tip?
Yes.
Yeah, because you foiled it out, right? Which I have to tell
Yeah.
you, everybody's
You called it out.
trying to do that. But if I have x cubed, right? How do I get x all by itself?
Oh. You
Take.
You-
Oh, you can't see my screen here.
No.
I'll share my screen with you here. Yeah, if I have x cubed, right? I just take the cube root.
yeah. Okay.
That'll make your problem a whole lot easier, I think.
But you have to do it to both sides, right?
Got to do it to both sides. That's exactly right.
Wait. But we have y plus 2 cubed.
Yeah.
Okay, so let's. I have f. Let me get a pencil here. I have f of x equals -1 plus x plus 2 cubed, and you made this a y. -1 plus x plus 2 cubed, and then you switch the x's and y's. You have x equals -1 plus y plus 2 cubed. That's where you got to, correct?
Yeah. Well,
We we added the 1.
Okay, great. So now we have x
yeah.
plus 1
That's one.
is equal to y plus 2
Cubed.
cubed.
Yeah.
Okay, I want to get y by itself, don't I?
Mm-hmm.
Cube root. Cube root. This side here, I have the cube root of x plus 1. And what do I have on this side?
Y plus.
Yeah, y plus
Two.
2.
I got y plus 2. Now I want to get y all by itself. What do I do?
Subtract 2 on both sides.
There you go.
Good.
All right, good.
Yeah. Thank you.
You're welcome.
Yeah.
So then would it be the cube root of n minus 1?
It would be the cube root, but cube root of x plus 1 minus 2 because you can't.
How we doing?
Doing okay, I think.
Are we doing all right?
The second one.
Second one throwing you for a loop?
Yeah.
Yeah.
Yeah, so let me show you a little trick here. So I'm going to share my screen with you. I think I can do that. Yeah. Okay. So if I have for example x cubed and I wanted to get it x all by itself, what would you do?
Take the cube root.
That's exactly what I would do. I take the cube root and then I would get x all by itself, right? Are you with me?
Oh, yes. Yes.
So I'm guessing that you guys have gotten something like you've probably gotten down to about here, right? Can you see my screen? Have you gotten this far?
Yeah.
You got that far, everybody?
Yeah.
Okay. So, and then you add 1 to both sides to kind of get this piece here all by itself. Then take the cube root. Am I making sense? Alex,
So-
am I making sense?
I think so.
Clark,
So it would be x plus 1 equals y plus 2 cubed.
so yeah, so if we got to here where we switched the x's and the y's, right?
Mm-hmm.
Then I'm adding 1 to both sides. I get y plus 1 is equal to x plus 2 cubed, right? I'm sorry. I switched that around. It should be, I'm sorry, here, let me go. It should be x plus 1 equals y plus 2 cubed, right?
Right.
So
And then cubed root.
cube root,
Okay.
cube root. So I now have the cube root of x plus 1 equals what?
Y plus 2.
Equals y plus 2. So now what do I need to do to get y all by itself?
Subtract the 2.
There you go. See it? We're good?
Yes.
Okay, carry on. I'll see you back in the main room in a minute. Everybody back? So did we, I am guessing that this one worked out okay, and that there was more difficulty with this one right here. Is that correct? Did we get it? I need to hear back from some people. Hello?
I can't see the screen.
Yeah, you can't see the screen. Well, that's bad on me, isn't it?
I can't see the screen either.
There, now can you?
Okay, yeah.
Okay, I thought I had shared it, but I guess I hadn't. So I was saying my guess is that the first one went okay, but the second one was causing trouble. Yeah? All right, so here's what I'm gonna do, because it's time for lunch, is I'm gonna let you go, and I will just make a short video of how to do that problem. And I will email it out, and then everybody will be kind of on top of it. But the key to that problem is realizing that if I want to get, if I have x cubed and I want to get it all by itself, I just got to take a cube root. Okay? So go have lunch. Enjoy the rest of your day as best you can, locked up in the house. And we'll see you on Thursday, all right? You have any questions, come email me. We'll do a little Zoom chat.
Thank you.
Okay,
Thank
guys.
you.
See you later.
Thank you.
Okay, 1 second, Alondra. Give me a second here. How do I do this? Okay, I'm going to stop share. And I'm going to stop recording. Did I do that? No.